Okay, first we are going to learn what is the meaning of matrix. What is that, right? Then after that, we'll learn some basic operations that involve matrix, involve the operation of plus, minus, multiplication activities. Okay, then after that, we'll also learn what is the meaning of inverse matrix, followed by solving the simultaneous equation using the matrix concept. Okay, so these are the subchapters that we are going to cover for chapter number 6. Okay, so let us try to proceed to the next slide. Okay, so what is a matrix? So matrix actually is referred to array of numbers, okay, which are arranged in the we call it the rectangular format, and all these numbers are arranged in the proper rows and proper columns, okay, and with a pair of brackets, just like this. Okay, and the whole matrix, usually we use a symbol to represent the whole matrix. We use capital letter usually, yeah. Let's say we can use A, capital A to represent the whole matrix. Okay, and usually we'll analyze the location of the number, yeah, based on row and column. So this is the first row, okay, for matrix A. This is the first row, 1, 2, 3, 5. These 3 elements are in the first row. Okay. And the number of 1, 0, 6 are in the second row. Okay. Then column, how to look at the column? Okay, column, for this matrix, there are 3 columns. The first column is this one. These 2 elements are in the first column. And 2 and 1 are in the first column. And 3, 0 are in the second column. And 5, 6 are in the third column. Okay. And all of the elements inside this, all of the numbers of the value are inside the matrix we call as elements. So for matrix A, there are 6 elements altogether. Okay. And for each element also we will give a name for each element. Okay, depends on the location of the row and column for that number. Let's say this number 2. Okay, this 2 1. 2 is at the location of row number 1 and column number 1. So this 2 will give a name. We can set this as A11. Okay, A11. So the first digit of this 1 here is referred to the location of the row. Okay, and this J is referred to the location of the column. Okay, maybe we can pick up one number again. Number 4. Let's say number 4. This one. Number 4 is at the location of first row and second column, right? So we can name this 4 as A12. A12. Okay. 1 means this number is located in row number 1. 2 means this number is allocated at column number 2, second column. Okay, let's pick up another number, number 9. Let's say number 9, which is this one. So 9 is at the location of row number 2. Okay, row 2 and third column. So we can name this 9 as A23. Okay. The name for this 9 is called as A23. In order to specify the location of the row and the column for this number. Okay, if the number of rows and number of columns for a certain matrix is equal, same number of rows and same numbers of columns, then we can name these matrices as square matrix. Okay, so example of square matrix will be like this, matrix B, okay, whereby the number of rows and number of columns all are equal to 2. So this is the 2 multiplied 2 order of matrix. Another example will be matrix C. For matrix C, how many rows altogether? 1, 2, 3, 3 rows. And how many columns? 1, 2, 3. So because number of rows and number of columns are the same, we can name this matrix as square matrix. Yeah. Okay. Then we proceed to the next example, matrix D. Matrix D, okay. And we can check how many rows? Only 1 row, right? Only 1 row. And how many columns? 1, 2, 3, 3 rows. So we can say that this D matrix is has the order of 1 multiplied 3. Okay, has the order of 1 multiplied 3. Because only 1 row and and 3 columns. How about E? Matrix E has 1 row, 2 columns. So matrix E has the order of 1 multiplied 2. Okay. Matrix F. Matrix F have how many rows? 3 rows. Huh? 1, 2, 3, 3 rows, but only 1 column. So matrix F is the matrix that have order of 3 multiplied 1. G has 2 rows, right? 1 column, 2 rows, 1 column. So it's order of 2 multiplied 1 matrix. Okay, next. Identity matrix. What is the meaning of identity matrix? Identity matrix means like when all of the numbers at the principal diagonal are all 1, and then the beginning numbers are 0. What is the meaning of diagonal? Diagonal means the numbers or the elements which form a straight line from the top left corner to the bottom right corner will form a straight line. Then all these numbers or elements are called as the diagonal elements. Okay. So in this case here, the diagonal elements will be this, and this one. Form a straight line from the top left corner to the bottom right corner. So these 2 numbers are considered as diagonal elements. Right? So if you see the diagonal elements are 1 and other numbers are equal to 0, then we can conclude this is the identity matrix. Okay, identity matrix. Another example would be this one. Okay, you may find that the diagonal numbers all are equal to 1, and all other numbers from other elements are equal to 0. So this is an example of identity matrix as well. Okay, if two matrices we can conclude as equal. Okay, when the order of these 2 matrices are similar. Order means same number of columns and same number of rows. And then we can conclude these 2 matrices are equal, similar. Okay, if equal, that means we can calculate the element value in each of the matrix. Let's say for this question here. Okay, if this matrix on the left hand side is equal to the matrix on the right hand side, then we can conclude A is equal to 5. Why? Because the location for A and 5 are similar. Right? Location means same row and same column. Same row, same column. Right? For A is at the location of row number 1, column number 1. 5 is also at the location of row number 1, column number 1. So we can conclude A is equal to 5. Okay? Because both elements have similar position of row and also column. How about B? B value is equal to 1, right? Because B is at the location of row number 1 and column number 2, which is similar to this location. Okay, so we can conclude B is equal to 1. C is equal to 2, right? Because C is located at the column, okay, row number 2 and column number 3, which is this number. Okay, so for example, I just want to test understanding of the row, the order of the matrix. Okay, so let's try question A, 1A. So it seems to be this is the square matrix because number of columns and number of rows are similar, right? Same number of rows and number of columns, which equal to 2. Okay, so for this question, how many rows altogether? 2 rows. This is the first row. First row is 3, 1 is at the first row. 0, 5, second row, right? So that means for this matrix, there are 2 rows. How many columns? 3, 0 are in the first column. 1, 5, second column. So for this matrix, is the error of 2 multiplied 2. 2 rows and 2 columns. Okay, how about this one? 5 plus m. The element of this is 5 plus m. So there is only one element in this matrix for B. There's only one matrix. One element only in this matrix. All right. So for this matrix, how many number of rows? Answer is 1. Right. How many number of columns? Only 1 also. 1 column. Because 5 plus m is considered as one number, one element. Okay. So that means for this matrix, there is only one column. Okay, so in short, we can conclude this matrix is the error of 1 multiplied 1. One column, one row, and one column. Huh? The first number should be the row, and then the second number is the column. Okay, C. Okay, for C, there are 2 elements. Okay, and all these 2 elements are in the same row, right? First row. So number of rows for this is 1. Right? Number of column is 2. So it's 1 multiplied 2 at row matrix. Okay, D. D has how many rows? 3 rows. 1, 2, 3. 1, 2, 3. Yeah? And then column, only 1 column. So it's 3 multiplied 1 error of matrix. Okay, example 2. Example 2 is when asked to solve the problem for the matrices. That means we need to identify the value of the unknown variable. Okay, so for part A, there are 2 unknown variables which are x and y, 3x, y. All right. So this matrix is consists of how many rows? 2 rows, right? 2 rows and only 1 column. Okay, on the right hand side we have 12, 5. If you analyze the pattern of the matrix, is also two rows and 1 column. So that means the error for both matrices are similar. So we can conclude these 2 matrices are equal. Okay, because these 2 matrices have the same number of rows and number of columns. So these 2 matrices are equal. If equal, then we can solve the problem. Okay, step by step. So for 3x, because the location is at the location of row 1, column 1. 12 is at the location of column row 1 or column 1, same position. So we can conclude 3x is equal to 12. 3x is equal to 12 because these 2 elements have similar position of column and row. Okay, so we can write down 3x equal to 12 and then solve the problem for x. X is equal to 4. Okay, then how about y? Y is very direct. Y is equal to 5. Okay, because y and 5 have the same location of row and column. And part B, we have 2 elements. Okay, 2 elements on each matrix at both sides. Okay, so on the left hand side we have 2x plus 1 followed by 9. On the right we have 7 and 3y. Okay, so how are we going to get the x value and y value? We have to solve 1 by 1. Right? So 2x plus 1 method is at the location of row number 1, column number 1, which is similar to this location. So we can conclude 2x plus 1 is equal to 7. Okay. Then we simplify this by transpose the formula, let the x as the subject. So we move 1 to the right hand side becomes minus 1. So 7 minus 1 is equal to 6. Then lastly move 2 to the left hand side becomes divided by 2. So 6 divided by 2 is equal to 3 positive. Okay. So x is equal to 3. Okay, y? Okay, 3y is equal to 9 because both elements have the same location of column and row. So we can conclude 3y is equal to 9. So y is equal to 3 positive. Quite easy, huh? Okay, next. Okay, I think we go through together. Question number, example 3, part A, also had to solve the problem for x and y. Okay. Okay, let us analyze first. Make sure that both sides have equal number of columns and rows. Okay, how many rows altogether? Two rows. Okay. How many columns? 1 column. Okay, then we can conclude the matrix on the left hand side is equal to the matrix on the right hand side. Okay. So which row should we solve first? We should solve row number, the first row, because first row only involves 1 variable, which is x. Second row has 2 variables, x and y. So it's better to solve the problem for row number 1. So we can conclude x plus 5 is equal to negative 3. X plus 5 is equal to negative 3. Okay. Then what can we do is transpose the formula so that the x will be the subject. So we move 5 to the right hand side because minus 5. So negative 3 minus 5 will get negative 8. Okay. And then we solve the problem for row number 2. X plus y is equal to 3. X plus y is equal to 3. Okay, I use different number. Different color as well. Maybe this one I use purple. Okay. Therefore, the next step. Next step is to substitute x equal to -8 to here. And replace x equal to -8 to this equation so that we can solve the problem for y. Okay, so in order to get the y, we have to transpose the formula, move the negative to the right hand side, becomes +8. Okay, y equals to 11. Okay, then example 3b. 3b, we need to solve the problem for x and y as well, variable x and variable y. Okay. Before we solve the problem, we need to check first both sides, make sure that both sides have similar number of rows and columns. Okay, so this is a 2 multiply 2 matrix. Okay. On the left hand side, we have 2 columns and 2 rows. Right hand side also 2 columns, 2 rows. Okay, then we can solve the problem using the equation. Okay. So which one should we solve first? We know that okay, for this number is 0, 0, 1. Okay, same. Better solve this one first, right? Better solve this x. Because this one got x and y. For the location of row number 2, column number 1, it's more complicated because it involves x and y. So it's better to solve this one first. Solve the problem for location row number 1 and column 2 first. Right? So from here we can conclude x is equal to 2. Okay, then the next step is we try to substitute x is equal to 2 to this equation, which is x is equal to y plus 4. So it's substitute 2 into the x. Get the answer for y is equal to -2. So for until now, that means that you need to know the location of the element in terms of the number of row and number of column in order to solve this problem, right? So far so good. Okay, the next section is we're going to learn how to solve the mathematical operation that involve plus and minus activity of the matrices. So we'll start from the summation activity first. Okay, so now let's say we have matrix A and matrix B. Okay, you are asked to calculate the value for matrix A plus matrix B. Okay, we can only use matrix A plus matrix B only exists when both matrices have same number of rows and same number of columns. Okay, if the two matrices have different rows and different columns, then we cannot sum up these two matrices together. Okay, so make sure that if you want to sum up the two matrices, make sure that these two matrices must have the same number of rows and same number of columns. Otherwise, the summation of the matrix does not exist. So okay, for A and B, okay, both matrices have the error of 3 multiplied 3, 3 columns and 3 rows and 3 columns. All right. If that's okay, then we can sum up these two matrices now. So we can conclude. We can write down this equation now. Okay, quite a number of numbers we have to write down. All right. Then how to sum up? Sum up is we need to sum up the A11, right? Then followed by A12, A13. Okay. So in this case, we need to sum up this A11 with this B11 because these two numbers share the same row and same location of column. So this 10 and this 2 can be summed up together. Okay, because these two elements have the same location of row and same location of column. So these two can be combined together, becomes 12. Okay, so continue the same until this last column and last row. This is 90 plus 7, I get 97. So you may find that the result of the matrix of the summation should be also equal to 3 multiplied 3 matrix. The result must have the same number of rows and same number of columns compared to A and B matrices. How about subtract now? Are we going to subtract the two matrices? Can, okay? Given that these two matrices have the same number of rows and same number of columns also, just like C and D. So for C and D, the matrices have how many number of rows? 2 rows, right? And how many columns? 2 columns. So it's 2 multiplied 2 for the row. Okay, in this case, we can subtract. So how we have to use the front matrices. Okay, one matrix minus the matrix at the back. Okay, so depends on the question. If C is in front, that means we have to put C in front, followed by D. Okay, how to subtract them? Okay, so that means we need to subtract based on the location of the element. 10 can be combined, can subtract the two, because these two elements are in the position of row number 1 and column number 1. So we can subtract using 10 minus 2. Okay, so make sure that you use the element from the C matrix minus the element from the D matrix in order to solve the problem. Okay, so 10 minus 2 will get 8. Then we'll move on to this number. This number is column number 1. This is row number 1, column number 2. Column number 1, row number 1, column number 2. Okay, so we have to use this 20 minus 3. So we'll get 17. Then 30 minus 0 is equal to 30. Then lastly, use 40 minus negative 5. 40 minus negative 5 becomes 40 plus 5. So it's equal to 45. So this one, be careful. Okay, I better use red color. 40 minus, again, minus negative 5. So it becomes 40 plus 5. I better use red color to remind you. So I get 45. Okay. Next is, okay. The next is multiply a matrix by a scale number, scalar number. Okay. Let's say, okay, if n is equal to this matrix, this one is 2 multiplied 2 matrix, and you're asked to get a k multiplied m matrix if k is equal to 2. Okay, if k is equal to 2, what is the meaning? That means you're asked to calculate 2 multiplied m. Okay, 2 multiplied m. So what is the meaning of 2 multiplied m? That means we need to multiply 2 with all of the elements inside the m matrix. So that means we need to use 2 multiplied with 1, followed by 2 multiplied 2, 2 multiplied 3, and 2 multiplied 4 for this number. Okay, so I'll get 2, 4, 6, 8. Got easy, this. Okay, next. Okay, these exercises, I think I just let you do at home. Then we can discuss during the tutorial this week. Okay, if you got any problem. Okay. Okay, the next section is still involve multiplication activities of two matrices, right? But be careful, before we can conduct any multiplication activity of product operations for two matrices, we need to check the number of rows and number of columns for both matrices. Okay, what is the reason we say so? Is because the two matrices can only be multiplied together if the number of columns in the first matrix is equal to the number of rows in the second matrix. Otherwise, the product of the two matrices will not be exist. Okay, so we only can perform multiplication of two matrices. Okay, if the number of columns in the first matrix is equal to the number of rows in the second matrix. What's the meaning? Okay, let us try one example here. Okay, so assume that now matrix A is equal to this. This is matrix A. This is matrix B. Right? So for matrix A, how many number of rows and number of columns? So for matrix A, we may find that there are 2 rows. And how many columns? 3 columns, right? 1, 2, 3, 3 columns. So we can conclude matrix A is the error of 2 multiplied 3, right? 2 multiplied 3 matrix for matrix A. How about matrix B? Matrix B has 3 rows, and 2 columns. So matrix B is has the order of 3 multiplied 2. Okay, 3 multiplied 2 order for matrix B. Okay, now we check. If you compare A and B, the number of columns in matrix A is exactly equal to the number of rows in matrix B, right? Same, right? 3, 3, 3. If that's the case, that means we can multiply these two matrices together. Okay, because the number of columns in the first matrix is 3, yeah, which is equal to number of rows in the second matrix, which is also 3. Otherwise, we cannot multiply these two matrices together. There will be no result. Okay, answer is no result if both numbers are not similar. Then there will be no result. Okay, that is the rule to perform the product of two matrices. So far so good. I think somebody want to ask question, right? Anybody want to ask question? I heard some noise. I think from Steve or some. Okay. Is that from Mirza? Mirza, do you have any question to ask? Today we have quite a number of students attend online class. Huh? I think it's Mirza, because unless you want to mute your mic, Mirza. Okay, I continue. Huh? If no question, okay.
Let's see if at the end
I think Mirza want to ask question. Okay. Mirza, you may need to mute your mic. Do you have any question? Morning, Mirza. Can you hear me? You need to mute your mic. Hello. Okay, if not, then continue. Okay. So if these two matrices can be multiplied, then what will be the result? What will be the output? The output will be the matrix of 2 multiply 2. Okay, the result of this matrix multiplication will form 2 multiply 2 matrix. Okay, how do we know? It's from here. Okay, 2 multiply 2 matrix. Okay, so let's try now one by one how to do so. Okay, so if 2 by 2 matrix, that means there'll be 2 rows and 2 columns. So let's try to perform to get the value for the number in the first row and first column. Okay, first row and first column, which is A11. A11. So how to do so? Because it's A11, so that means it's involve all the numbers. Okay, all the numbers on the first row of your first matrix. Okay, if that is the case, I'll just hide the second row. Okay, temporarily I hide it. Now we want to focus on this one. How to get this part. The element for the first row and first column. How to form 2A, 3B, and 4C. So now I want to show you the step. How to get this value one. Okay. You may find that the location of this element is at the row 1, column 1. So that means we'll involve the elements of first row from the first matrix, which is matrix A, multiply with the elements in the first column of the matrix B. Okay, so if there's a case, I'll hide this because this will be not relevant. Okay, in order to get this value one. Okay, so that means this element here, the end result is how to form that is we have to use 2 multiply A plus 3 multiply B plus 4 multiply C in order to get the element at the row of number 1, column number 1, which is this thing here. So it's formed by the number in the first row of matrix A multiplied with the number in the first column of matrix B. Okay. Then how about this one? 2D, 3E, 4F. How to form this? Okay, the location of this element is in row number 1, right? Row number 1 and column number 2. Okay, so if that's the case, that means we need to use the matrix, the first matrix, which is matrix A. All of the first row will be involved. Then multiply with the element in the second column of the matrix B, which will be this. This is second column of the matrix B. Yeah? So we need this row and this column to get the answer for this element. Why? Because this element is at the location of row number 1 and column number 2. So let's try now. So it's 2 multiply D plus 3 multiply E, then plus 4 multiply F. Okay, now move on to this element. This element is at the location of row number 2, second row, right? And column number 1. If that's the case, you'll involve this row, the second row, and then column number 1 of the B matrix. So let's try to perform. Okay, 5 multiply A, I get this, plus 6 multiply B, get this one, and then plus 7 multiply C. This is the final answer because A, B, C are different variables, so we cannot combine the like terms. There is no like term. Yeah, so just leave the answer until here. Okay, last element is this one. This element is at the location of second row, second column. What's the meaning? That means, like, in order to form this element, we need to use the numbers in the second row of the matrix A multiply with the number in the second column of matrix B. Okay, so involve this row and this column. So I hide. Okay, usually I hide, even though still not experience. Sometimes I have experience. I still want to hide so that you're not confused. Numbers involved, right? So in the exam also, you can just simply use maybe use hand or something, or use paper to hide column and row, which are not relevant. Yeah? Okay, so let's try to check the answer. So for this element, it's formed by 5 multiply D plus 6 multiply E, and then plus 7 multiply F. Okay, one example is not enough. Let's try another example because some seems to be slightly complicated. Okay, let's try another example. Well, it seems to be more challenging now. Okay, you are asked to multiply these two matrices together. Okay, before we perform the multiplication activity for these two matrices, we need to check first. Make sure that the result for these two matrices of production is exists. Okay, so let's try to check first. This matrix has 3 multiply 3. 3 multiply 3 error. Okay, this one 3 multiply 3 because same matrix error. So confirm can multiply these two matrices together and can get a result. Confirm because both matrices have the same number of columns and same number of rows. Okay, you can, if you don't believe, you can check here. Okay, the number of column in the first matrix is exactly equal to the number of rows in the second matrix. 3, 3, same, right? So that means the multiplication result of these two matrices exists. Yes. Okay. So now we can confirm. Okay. Before we can continue, better also try to check also what will be the result, the output of this production. If we multiply these two matrices, what will be the outcome? Okay. What is the error of the outcome? So you may find that the error of the outcome should be 3 multiply 3. Right? 3 multiply 3. So that means the result will be have 3 rows and 3 columns. Okay, 3 rows and 3 columns. Okay, so now we start from this element. This element is at the location of first row and first column. First row, first column. Okay, so that means we need to hide other rows and other columns. So I'll hide this. In order to get this element value 1, first row and first column, we need to only focus on first row for the front matrix, followed by the first column of the second matrix. Okay. Other columns and other rows just hide. Okay, let us try to check. What is your answer? Okay, so for this element is using 1 multiply A plus 2 multiply D, then plus 3 multiply G. They can get this answer. Okay. So let us try maybe this one, how to get this. Right? Okay, I think I better you do one by one. Okay, this is at the location of row number 1, and second column, okay, second column, row number 1, second column. So how to form this? So that means we need to use the first row front matrix multiply with the second row, second column, the second column of the second matrix. So that means we need to hide these two columns. We just focus on the second column of the matrix B, right? Okay, so let's try it. So 1 multiply B, you'll get 1B, plus 2 multiply E is equal to 2E, and then plus 3 multiply H, you'll get 3H. Okay. So continue the same process until this element. This element is at the location of third row. Third row one, third row and third column. Third row and third column. Okay. So how to perform then? Third row, that means we need to hide the first two rows. Just show the third row value one, third row elements in the first matrix. All right. And then show the elements for the third column of second matrix, which is this one. So we need to hide the first two columns. Okay, and they show the third row of first matrix and third column of the second matrix. So let's try to perform now. Okay, 7 multiply C, you'll get 7C, plus 8 multiply F, plus D, plus 9 multiply I. So you'll get this element. So for matrix, if the matrix involve multiplication activities, then you need to perform this. So probably it's new for you. You need to do some exercise, practice in order to familiar with the steps involved. But it's playing around with number of rows and number of columns. Okay. Number of rows and number of columns. Okay, we have some more examples. Okay, let us try one more example. So this matrix we have, the first matrix is 2 rows, 3 columns. So it's 2 multiply 3 matrix, right? 2 multiply 3, so I write down here. And then this one we have 3 rows, 2 columns. So I put here. The error for the second matrix is 3 multiply 2. Okay, then now let us check if we multiply, are we able to get a final answer if we multiply these two matrices together? So we compare the number of columns in the first matrix and also the number of rows in the second matrix. Same 3, 3. So that means there will be a result if we multiply these two matrices together. Because number of column in the first matrix is equal to number of rows in the second matrix. Okay, then how about the result? The end result, if we multiply these two matrices, end result is 2 multiply 2 matrix. The end result is 2 multiply 2. So that means the end result has 2 rows and 2 columns. Okay, so let us try to perform now. Okay, so in order to get the answer for the location of first row and first column, which is this number 80, how to get the answer? Okay, so that means we need to use the elements in the first row only of the front matrix, multiply with the elements in the first column, second matrix. So we need to hide this row and this matrix. We just focus on the first row of the matrix A, multiply with the first column of matrix B. So let's try to perform now. Okay, one by one. So 2 multiply 10, you get this, plus 3 multiply 8, then plus 4 multiply 9. So simplify this element. Okay, answer is equal to 80 for this part. Okay. Then how about this element? This one is at the location of row number 1, column number 2. Okay, row 1 is from here, column number 2, that means we need to use this element, these elements now. Okay, let's try. So 2 multiply 20, we'll get this, right? Then plus 3 multiply this number, which is 30, and then plus 4 multiply 40. So the end result is 290. Okay. How about this one? This is second row, second column. Second row, that means we need to use the second row of the matrix A, multiply with second column of matrix B. Okay, let's try. So 5 multiply 20, you get this, plus 6 multiply 30, and then plus 7 multiply 40. Answer is equal to 560. So if involving multiplication activity of two matrices, you really have to plan properly. Okay, before we perform the multiplication activities. I think this one will go together. Okay, I think we do together because okay the format of the matrices can be different for both matrices. So let's try to perform together. Okay, okay. First question. First question. Okay, this matrix is 1 multiplied 2 error. This one is 1 multiplied 2 because it's got 1 row and 2 columns. So I put here 1 multiplied 2. Okay, on the right hand side, just of our planning. Second matrix is how many rows? 2 rows, 1 column. So this matrix has the error of 2 multiply 1. Are we able to get the answer for these two multiplication matrices? Yes, can. Why? Because you may find that the number of column in the first matrix is equal to the number of rows in the second matrix, 2, 2, right? So that means there will be a result if we multiply these two matrices together. Okay. Then what is the output? If we multiply these two matrices, what will be the output? Answer is 1 multiply 1. How to get 1 multiply 1 is from here. Okay. Answer will be 1 multiply 1 answer. So that means there is only one column and 1 row for the final answer. Only 1 element inside the final matrix. Only 1 element. That will be the end result. If we multiply these two matrices together. So how to get the answer? Answer will be the first row of the front matrix multiply with the first column of the second matrix. All right. So it's 2 multiply negative 1 plus 3 multiply 5. So 2 multiply negative 1 is negative 2 plus 3 multiply 5 is equal to 15. Okay. So you get 13 answer. There's only 1 element in the final answer. Answer is 13. Okay, try one more example here. Now, okay, question 2. I try to increase the size so that those who sit at the back can see. So we can see, okay. Question 2 is we are asked to multiply 5, 3, and 4, 6. So before we perform, it's better to check first. Okay, for the first matrix, how many rows and how many columns? Answer is 2 rows, 1 column. So write down 2 multiply 1 for the first matrix on the right hand side. Second matrix we have 4, 6. 4, 6 is consists of how many rows and how many columns? 1 row and 2 columns. Okay. So write down here 1 multiply 2 for the second matrix. Okay, and then check whether the number of column in the first matrix is equal to the number of rows in the second matrix are same. So that means there will be a result if we multiply these two matrices together, because 1, 1, right? Same. Okay. Then if we multiply these two matrices, what will be the outcome for these matrices? The outcome will be a matrix which is 2 multiplied 2 a row. That means there will be 2 rows and 2 columns. The end result will be 2 rows and 2 columns. Okay, so let's try to perform now. So how to get the element for first row and first column? First row, first column, that means it's involved this. First row, first row is only this, right? And first column is this one only, this number. First row, first column. First row, first column. I just said first row of matrix A multiply with first column of matrix B. I treat this as A, this is a B matrix. So multiply 5 multiply 4, you'll get 20. 20. Then how about this one, 30? How to form this 30? Okay, this 30 is at the location of row number 1, column number 2. So that means we need to use row number 1 value multiplied with column number 2. I use purple. Row number 1, matrix A multiplied with column number 2, matrix B. Okay, so get 5 multiplied 6 equal to 30. Okay. Similarly, also, okay, for this element is at the location of row number 2, column number 2. So we need to use the second row for matrix A multiplied with the number in the second column of matrix B. Okay, then you'll get 3 multiplied 6, answer is equal to 18. Okay, let me scroll down. Okay, then we'll move on to question number 3. Because it sounds like multiplication activity for matrix is quite complicated. So let us try, because the pattern of the two matrices can be different arrangement. So let us try another example. So you can see. Okay, question 3. Question 3, the first matrix is involved 2 multiplied 2, 2 columns and two rows and 2 columns. Second matrix is 2 rows and 1 column. So we try to write down first the matrix error for both matrices. Right? So for matrix A is 2 multiplied 2, matrix B is 2 multiplied 1. This one is 2 multiplied 1 error. Okay. So you may find that the number of columns in the matrix A is equal to number of rows in the matrix B. Yeah, same. So that means we can multiply these two matrices together. Then how will be the result? The result will be 2 multiplied 1 matrix. Okay, the output for this multiplication activity will end up with 2 multiplied 1 matrix. So that means it'll be 2 rows and 1 column. Okay, 2 rows and 1 column. Okay, so let's try to check. Okay, this one. How to get the value for first row, first column? First row, first column, that means we need to hide. Okay, I try to use the bar that I drawn just now to hide. I copy this. Oh, I already have the bar here. Okay, so in order to get 14, we need to use the first row in the matrix A, multiply with first column of matrix B, right? First row of matrix A multiply with first column of matrix B in order to get 14. So let's try to check how to get 14. So we need to use 2 multiply 1 plus 4 multiply 3. 2 multiply 1 is equal to 2. 4 multiply 3 is equal to 12. So simplify, you'll get 14. Okay. Then how about this one? This is row number 2, column number 1. How to get 21? Row number 2 of matrix A. Row number 2 is here, second row of matrix A. Multiply with first column of matrix B. So we need this row and this column. Okay, let's try. 6 multiplied 1 is equal to 6, right? And then plus 5 multiplied 3 is equal to 15. So get 21. Okay, this one I try to go slowly because since be slightly complicated for most of us. So I try to go slowly with more examples. Okay, now we move on to question number 4. Question number 4 also got 2 matrices and both have similar error. 2 multiplied 2. So confirm can multiply together because both matrices have the same number of columns and same number of rows. So confirm and get the answer. And then the final answer must be 2 multiplied 2 matrix. Okay. So if 2 multiplied 2, we need to fill in the blank. So how to get 5 here? This is row number 1, column number 1. Row number 1, column number 1. So we need to hide something which are not necessary. try to hide. Okay, I move this one to here. I hide the second row. In order to get this value, because we know that this value is at the location of first row, first column. So we need the first row value for matrix A and also the first column value for matrix B. So I hide 2, 1. 2, 1 need to be hidden. If that's the case, I try to use this bar to hide. I hide this. Okay. Try to increase the size. So now our target is we want to get a 5. This value is at the location of row number 1, column number 1. So we need this row of value plus this row of this column of numbers. Okay, so let's try to check how to get 5. So it's 2 multiplied 4 plus negative 3 multiplied 1. 2 multiplied 4 plus negative 3 multiplied 1. Okay, so you simplify, it's 8 minus 3, you'll get 5 positive. Okay, then how about negative 10 here? Okay, this number is at the location of row number 2. Row number 2, second column. Okay, if row number 2, we need the second row number for matrix A multiply with the second column from matrix B. Okay, in order to get negative 10. So let's try. Negative 3 multiply 2 plus 4 multiply negative 1. Negative 3 multiply 2 plus 4 multiply negative 1. So answer is equal to negative 10. Okay. Any more example? Okay, last one for multiplication activity. Question number 5. Question 5, the first matrix A is 2 multiply 1 matrix. 2 rows, no, 1 multiply 2. 1 row and 2 columns. So it's not 1 multiply 2 for matrix A. Okay, then write down 1 multiply 2. And then the second matrix, which is matrix B. Matrix B is 2 multiply 2 from form 2 multiply 2 arrow. So I'll write down here, right? And then we check first whether the number of column in the matrix A is equal to number of rows in matrix B or not. Same. Same, that means we can multiply these two matrices together. And then what is the result? Result is matrix 1 multiply 2. That means the end result will have only 1 row and 2 columns. 1 row, 2 columns, the result. If you want to multiply these two matrices together, so the result should be only 1 row and 2 columns. So let's try to check how to get this. 7. So 7 is using first row multiplied with the elements of first column in matrix B. So we need to hide this part. Okay, I move the bar to here. This one. See whether I can move or not, this bar. Otherwise, I have to create another bar. Okay, so now we try to get the value for 7, because this location is at the first row, first column, right? First row, first column. So then we need to use the elements from the first row of matrix A, multiply with the elements from first column of matrix B. So I'll hide this one, this column only. We only need this column only. Yeah? Okay, so how to form 7, which is 3 multiply 1 plus 1 multiply 4. You'll get 7. Okay, so for this element is involve first row of matrix A and second column of matrix B. Okay, second column of matrix B. So we need to use 3 multiply 3 plus 1 multiply 2 in order to get 11. Okay. So far so good. I think, okay, because the multiplication activity for matrix can have different format. So I think the best way to cope with this part is to do some more tutorial questions. Oh, we have some more else. Oh, okay. Example 5. Example 5, now we have 3 matrices, right? 3 matrices. A, B, and C. Okay, so for example 5, question number 1 is we need to calculate the multiplication operation that involves 3 matrices now. Okay, how to do so? If that's the case, we better just multiply the first 2 matrices. Multiply A with B first. Okay, then C will just copy down. Okay, let's try to check first the pattern for matrix A, B, and C. Okay, matrix A is 2 multiply 2 error. B is also 2 multiply 2. C also 2 multiply 2. So that means like A, B, C, we can multiply all these 3 matrices together because the matrices have the same error. 2 multiply 2. Yes, okay. And then another thing we should look at the output. What should be the final answer for this activity? Answer should be 2 multiply 2 also. Okay, the 2 multiply 2 error for the final answer. Okay, but because it involves so many matrices, we have to solve the problem for the front part. Okay, we try to focus on A multiply 2 B first. C, we just write down the elements, right? In the answer, we just write down first the element. We try to perform A multiply B first, the front part. Okay, so you'll get this one. So this is the result for A multiply B matrices. Then after that, we multiply with C in order to get the value for A multiply B and C. Okay. So try to do step by step. Multiply A and B first. Then after you simplify, they multiply with C matrix. Okay, yeah. Okay, how about this one? Question number 2. C power 2. C power 2 means C multiply C. That means matrix C has to multiply each twice. So you have to write down first the meaning. So C power 2 means C element had to multiply with C element. Yeah. Then simplify, your answer should be, the output should be 2 multiply 2 error. Okay. So we already done the second part for this chapter. The next is I'll introduce to you the inverse matrix. Inverse matrix, what's the meaning? So for inverse matrix, we are usually using the symbol of A power -1 to represent inverse of matrix. If matrix A is this one, so that means the inverse of matrix will use this symbol. A power -1 means inverse of matrix A, right? Inverse of matrix A. So what is the formula to calculate the inverse of matrix A? Formula is equal to 1 divided by determinant of matrix A, right? Multiply with a matrix. Whereby this matrix that we need to change the location of the original diagonal elements. That means for A and D, we need to change the position. Okay? Only change the position for A and D. Right? Then after that, we need to add a sign. Okay, we need to change the sign for B and C. If B and C are positive originally, we need to change this B and C as a negative number now in order to get we call it as the adverse of matrix A. Okay, so before that, let's try to do some exercise first. How to get the determinant which is this one, this symbol. How to get this one? Let us try first. We go to the fun slide. Okay, so if A is equal to A, B, C, D, yeah. So if you want to get the determinant of matrix A, we use this symbol. Okay, determinant. So what's the formula to get the determinant of matrix A? Answer is we have to use A, this element, multiply with D, minus B multiply C. Okay, so for instance, let's say B is equal to 7623. Yeah? If you want to get the determinant of B, then the answer is 7 multiply 3 minus 6 multiply 2. Okay, 6 multiply 2. So get 9. So similarly for C also, if matrix C is equal to this number, the determinant of C is equal to negative 5 multiply 3 minus negative 1 multiply with positive 2. Okay, so again negative 13. So good, huh? Okay, next. Okay, this one example 6. Huh? Let's say matrix A is equal to 5, negative 3, 4, negative 2. You are asked to calculate the inverse of A. Inverse of A, we use symbol power negative 1, means inverse of A. Right? So what is the formula to get inverse of A? Inverse of A is equal to 1 divided by determinant of A, then multiply with what? Multiply with, whereby you need to change the location of the diagonal. Okay, the diagonal of matrix A, change this location. Okay, 5 and negative 2, you need to change the position. And then for B and C element, we need to change the sign. Okay, originally this is negative B, this is negative 3, right? So now we need to change to 3 positive. And then this one originally is 4. Now we need to change to negative 4. Okay. Right, so let's try to perform now. Huh? Okay, determinant we have to use the original A. Okay, 5 multiply negative 2 minus negative 3 multiply positive 4. You'll get this part. Huh? So simplified answer is equal to 2. Okay, determinant for A is equal to 2. Okay, then lastly, we need to use 1 over 2 multiply in with all the elements in this matrix. Okay, so for this one, we have to use 1 over 2 multiply negative 1, and we'll get negative 1. Then 1 over 2 multiply with 3, you'll get positive 3 over 2. Okay, then 1 over 2 multiply negative 4, you'll get negative 2. Then lastly, use 1 over 2 multiply with 5, you'll get 5 over 2. Okay, one example is not enough. Let's try another example. See whether we have another example or not. No more example. Okay, it's okay, it's fine. Okay. So what is the reason we want to study this inverse matrix? Okay, the reason is because we can use the concept of inverse matrix to solve the linear equation problems at the same time. Okay, we can solve the x and y value or two variables simultaneously. So let us try this example. So let's say there are two linear equations which are 5x minus 2y equals to 2. And then another linear equation is 3x minus y is equal to 3. Now you're asked to solve the x and y value by using the matrix method. Okay, if you want to solve this problem, okay, we need to arrange all these coefficients of x and y and also the intercept into the matrix format. Okay, into the matrix format. Okay, so for all of the coefficient of x, we need to put as the first row. Okay, 5. So okay, so how to form this? Okay, so this one means 5 negative. This is 5x. 5x multiplied negative 2y is equal to 2 lah. Right? 5x multiplied with negative 2y is equal to 2. So we need to put in this way. Right? This is the coefficient of first x value, and this is the coefficient for the first y value. Okay, how about here? Here is the coefficient for the first x equation, and this is the coefficient for the y value for second equation. So we put here, right? So we need to allocate all these coefficient value into this format first. Okay, so that we can use the matrix method to solve the problem. Okay, so in order to get the xy, we need to move this matrix to the right hand side. Okay, if we move, that means this whole thing here, this matrix here, will becomes, we need to inverse this matrix if we want to move this matrix to the right hand side. So it becomes power -1. If power -1, that means this is the inverse matrix of this. All right. So how to get the inverse matrix for this one? That means it is using 1 divided by determinant for this. Determinant for this is 5 multiplied -1 minus -2 multiplied 3. Okay, you'll get the determinant for this matrix. Multiply with what? Multiply with the matrix where you need to change the location of A and D. You need to change, right? And then change the sign for B and C. Okay, location we need to change. So now 5 you have to put here. -1 you need to put at the top. Right? And then change the sign for B and C. Originally the B is this negative number. So now we have to change to positive number. And then the original C value is positive. Now we have to change to negative number. Okay. All right, then next is, okay, there are two methods. Either you can try to multiply these two matrices before we multiply in with this scale, right? Okay, if we simplify this part, I'll get 5 multiplied -1 is equal to -5. Minus -2 multiplied 3, I'll get -6 plus, minus -6, I'll get +6. So it's -5 plus 6, I'll get +1. Okay, so for this one, if you want, you can try to multiply these two matrices together first. But before that, let's check whether there is a result for this multiplication activity. So this is 2 multiplied 2. This one is 2 multiplied 1. Yes, we'll get the result for this. The result will be equal to 2 multiplied 1 matrix. This part, you'll get 2 multiplied 1 matrix. 2 multiplied 1, that means there will be two rows. Okay, 2 multiplied 1 is 2 rows, not only 1 column. The result will be 2 rows and only 1 column. Okay, so how to get the first row value and first row and first column? So that means we need to use this row, right? Multiply with this column. Okay, I try to use the bar again. I go back to get the bar to hide the unnecessary column or I think I get from here. Okay, let's try to get the value for the first row and multiply with the first column of matrix B. Okay. So how to get 4 here? 4, it will be -1 multiplied 2 plus 2 multiplied 3. So I'll get 4. Okay, how about 9? 9 is using the second row multiplied with the first column of matrix B. So -3 multiplied 2 plus 5 multiplied 3. So I'll get 9 positive. Okay, so that means we can conclude now the x is equal to 4 and the y is equal to 9 positive. So that means this question is asking us to use the inverse matrix, okay, in order to solve the simultaneous equation by using the matrix method. Okay, one more example. So for this question is, okay, 2 linear equations given to you. Okay, you are asked to solve x and y value using matrix method again. So if you want to solve the matrix method, that means we need to arrange these matrices into this format. So the coefficient of x and y for the first equation, you have to write down. Okay, this is the coefficient of x, coefficient of y. For the second equation, the coefficient of x is positive 1, coefficient of y is negative 2. So put here, right? Then write down multiply x, y. On the right hand side, you have to put the intercept value. 3, negative 3. This is for the intercept of first equation. This is the intercept for the second equation. Okay, then we have to move this matrix from the left to the right hand side. If we move to the right hand side, that means this whole matrix, we have to inverse the matrix. So that means we need to calculate the value for this inverse matrix, which is 1 divided by determinant of this matrix. Right, then multiply with the matrix. However, we need to change the location of this A and D. We need to change AD change, and then B and C we change the sign. Right, becomes negative for both. Then you'll get this. Okay, I try to highlight using red color. Okay, this one I use red color. Okay, seems to be the system not a lot hanging for a while. Okay, we continue. Seems to be I'm not able to change the color for this part, right? So here we need to get the determinant, 1 divided by determinant value for this matrix, then multiply with this. Okay, before we multiply this in, okay, we can try to simplify first. So this one I'll get negative 3 multiply negative 2. You'll get positive 4, right? Then minus 1 multiply 1, you'll get minus 1 here. So it's go to 3, positive 3 for this part. So after that, we can also simplify these two matrices by multiplying in. Okay? So this is 2 multiply 2 matrix. This is 2 multiply 1. 2 multiply 2 multiply with 2 multiply 1 can combine, can multiply together, yeah, because same number of row for the first matrix, same number of column for the first matrix, and same number of row in the second matrix. So we can combine these two matrices together. And the final answer for these two matrices should be 2 multiply 1 error. Okay, the result for this multiplication entity will be 2 multiply 1 error matrix. Okay, so how to get negative 3 here? Negative 3 because this value is at the location of row number 1, column number 1. So that means we need to use this row, first row, multiply with the first column of the second matrix. Okay, -2 multiplied 3 plus -1 multiplied with -3. So you'll get -3 for this element, right? This element, +3 is using -1 multiplied 3, then plus -2 multiplied with -3. You'll get +3 here. Then lastly, multiply with this k value, the scalar, 1/3 into each element, okay, both elements. So you'll get -1, +1. So that means the x value is -1, and the y value is equal to +1. Okay. Any other example? Oh, we have one more. Okay, one more example. Example 7 is also trying to solve the simultaneous equation using the matrix method. Okay. Okay, the first equation is x plus y equals to 11. Second equation is 4x minus y equals to 9. Okay. So if you want to use the matrix method, make sure that the equation for both should be already arranged in this format. Okay, whereby the intercept for the equation should be on the right hand side. You need to ensure that it is already arranged in this format. The x is in front, the first term, the second term should be y. Okay, then the next step is to change the format of this equation into the matrix format. Okay. So whereby we need to write down the coefficient of x and y for the first equation is this one, 1, 1, right down here. And then the coefficient of x and y for the second equation is 4, -1 put here. Then multiply with xy is equal to 11, 9. Then the next step is to move this matrix from left-hand side to the right-hand side. It becomes inverse matrix. That means we need to use the determinant, 1 divided by determinant of this original matrix, and then change the location of A and D value. You change the location, and then B and C, you need to change the sign. Okay. Simplify the determinant value first. Okay, meanwhile, at the same time, you can also multiply these two matrices at the same time, multiply together. Okay. Becomes matrix which involve only 2 rows and 1 column. Okay, 2 rows, 1 column only. If you multiply these two matrices together. Then lastly, multiply in the scalar value, which is 1/-5. Move in, okay, and multiply with this element and also this element. You get 4, 7. So 4 is the x and 7 is the y. Okay, so this is a summary. Summary we'll go through tomorrow during the tutorial. We'll go through together. So in short, okay, today what we have learned, the definition of matrix consists of many elements, whereby all these elements already been arranged in the rectangular format in terms of number of rows and also number of columns. Right? So today we also learn how to sum up the two matrices together. Okay? We also learn how to subtract the two matrices. We also learn how to multiply the two matrices together as well. And then lastly, learn how to identify or calculate the inverse of a matrix, and then use this concept to apply to the simultaneous equation to solve the problem of x and y at the same time. Okay, so that means we already covered the syllabus for this unit. We already done. So today will be the last lecture. Okay, there will be normal lecture coming week. Coming Monday there will be normal lecture. All right, I'll just let you do the revision by yourself for your test 2 on coming Tuesday. Our test 2 is on coming Tuesday. Anyway, this chapter will not be covered in your test 2. Your test 2 will only cover 3 chapters, which are chapter 3, part 1, we have financial mathematics, part 1 and 2. And chapter 4 will be your algebra. And then chapter number 5 is graphical analysis, which only involves linear equation analysis and break even. So this chapter will not be covered in your test 2, only covered in your final exam. So remember, our test 2 is coming Tuesday, 2 o'clock to 3 o'clock afternoon, Malaysian time. Okay, so this coming tutorial, we can discuss some of the matrix question in the tutorial. And if you got any problem, you can also ask question related to chapter 3, 4, 5. Okay. We can discuss some of the questions during the tutorial for chapter 3, 4, 5 in order to prepare for your online test 2. Okay. So coming week, Monday, no lecture, but we have tutorial. During the coming week tutorial, we'll discuss on the format of the final assessment, which is your final exam. Your final exam is online final exam with multiple choice question. I'm going to discuss with you during the next tutorial. Okay. So for online test 2, okay, are made available under the module. You should be able to access the link, okay, in the coming week. It's under modules. I try to go to the link to show you where is the module location for online test 2 coming week. I'm still waiting for the system to go to module week 12. It's under week 12 module. But the system is hanging here, the internet is hanging. Anyway, that will be here. Okay, you have to go to modules and then go to week 12 module for attend the online test 2. Yeah, the system is hanging. Cannot do much. Okay. Okay, any other questions on this besides the online test 2 and also the final project? Okay, I think there are some online students who want to ask questions. Let me see what are the questions asked by the online students. The system is hanging, internet. Okay, I try to use another computer, yeah, because it's hanging. Thanks, James. James are not allowed to ask questions. Yes, okay. Okay, I try to use another computer. Huh? Oh yes, already had. I think he can't hear you. Are you able to ask question, James? Any question from all of you, the online students? I think somebody want to ask question, right? Is that from James?
No, just now I was talking about Mirzam just now. He couldn't hear you.
Mirza cannot hear me, yeah?
Just now. Yeah.
Okay.
Okay.
All right. Thanks for
Thank you.
informing, James. Yeah. So for the online students, any question they would like to ask? Any question they would like to ask from the online students related to today's lecture?
No questions, sir.
Okay, no, okay, thank you, James. Yeah, thanks for, and Brian for responding. Thank you. All right, so I'll see you during the tutorial. We can discuss the matrix question plus also any question they would like to discuss for chapter 3 until 5, okay, in order to prepare you for your online test 2. So I'll see you during the tutorial. And then for your project 2, already extended the due date until today, 5 p.m. So you still can continue to do and then submit your report to before 5 p.m. today.
All right. Thank you.
All right. Thank you, Brian. Thank you for your response. Yeah. All right. So I'll see you during the tutorial. Okay. Bye-bye. I'll stop recording now. For the physical students, please remember to sign your name for your attendance. Right? Thank you for coming. Yeah. I'll see you during the tutorial this week. Okay. If you've got problem, you can step back and ask me questions on the project 2 if you want. Okay, then if not, bye-bye, Darren. Okay, bye-bye, Darren. I'll stop recording now.